Welcome guys. My name is Mishal Lamtairi, the owner of Emirates Astronomical Observatory. I wanted to do this quick video as I've received multiple questions on the science we do at the observatory since I've upgraded my gear. As you might know, I've upgraded my telescope to a Planewave CDK14 and a full-frame camera from QHHY. And how any amateur astronomer today can start capturing asteroids and helping the Minor Planet Center. I want to go into deep dive on how to find the asteroids, load them up on Stellarium, and transfer the data for the imaging software. I'd leave a different video for Tycho and Astronometrica where we analyze the data and how we can publish the data and send it across to the Minor Planet Center. That needs a full different video, so we'll keep it for another day. But for now, let's jump right into it. So to start off, guys, you'll need to go to the minorplanetcenter.net. That's the website that we use. And once you're on the web page, you can see you've got multiple options. And what we're searching for is under observers. You'd go to Neo Services and then Observation Planning Guide. Now, once you get to this page, it might look hard or difficult at the first time, but then trust me, everything is very easy to do. You just need to set up things once or twice, and then the memory on the PC would remember most of the things. You might have to manually plug in a couple of details, but it's not that hard or difficult to do. So we're going to start off with the range in the RA axis, and what I usually do is I keep this at 0 and then all the way to 360. This way it gives you a full 360 view of the rotation, so whether it's south, east, north or west, it's fine. And then under declination range, you'd need to find the sweet spot of the declination, and usually what I do is I keep it at plus 15. I know that underneath anything under 15 is usually blocked by my observatory, or worse off, the atmospheric interference would not let me capture any of the data. So I just go beyond the 15 level all the way to plus 90. And then from the magnitude range, now this depends on your equipment. If you have anything from a 10-inch and above with a fast optics of f3, f2 or even f4, you might get away with magnitude of 18 or 19. If it's a slower, smaller telescope, you might need to lower this to a magnitude of 16 or 17. In my case, I found it to be 20.5 is where I can capture details without worrying whether I can see it or not. So usually I just keep it at 20.5. And then, guys, for the motion range, I'd increase the 5 to the maximum you can do. So let's just put it at 222, and this way you're just opening it up. Any fast moving asteroid can be seen. If you limit yourself to 5 only, then any of these fast asteroids you won't be able to capture. So that's it. I'd leave the solar elongation as is, lower galactic as is. I'd leave all this fine. I'll just change this to only show objects not seen in more than 1 day. You can go to 2 days, 3 days, but usually if it's more than that, it's kind of lost. You'll never find it again. And then what we want to do is sort the selected objects as uncertainty and decreasing. Now, I have to say props to the team Asteroid Hunters. It's a father and son program that they started, and they were the reason I got into asteroid capturing as well. They've been very helpful. They show a lot of videos. You can find them on YouTube. They used to stream a while back on Twitch as well. And they have a similar video where they discuss all these information. So if you want more details, I'm more than happy for you guys to go see the channel. Shout out to Asteroid Hunters. They've been really helpful for me personally. So I'd move on, and then you have your observatory code. Now, if you're starting up, you wouldn't have an observatory code. That's fine. You don't need one at the moment. But it's a nice thing to have later on. I'm just giving you this insight on how you can do it just as a startup, and then from there you can build on. So once you have your parameters set, you press on produce object list. Now this is one of the bad things I found with the Minor Planet Center, is if you see the list, you can't automatically pick them all. You have to go one by one. So in the interest of time, I'll just pick the first 10 or so, and then I'll show you what else you can do there. So I think that's more than enough. So then once you're done, you'd go down and click this button, get ephemeridis. And you can see a list has populated with all the details that you need. If you look at the first one, for example, that's 2005 and E21. You'd find here further observation useful for orbit improvement. Now, sometimes you will find it as the one below, not necessary. So you don't really need to waste time on this. This is more useful for us. We're going to capture the data, send it across to the Minor Planet Center. And from there, they can realize, or they can put a trajectory on how the asteroid is moving and if it's a hazard to the Earth or not. You'd find a couple of people have already submitted their captured data. Velocity, which is the magnitude of 20.1. It's nice, you can easily find it, and then it's not a very slow moving object. So this is where the sky motion tells you how fast the object is going. So 4 or 5 is fine. You have another one below it, which is at 5.4 with a magnitude of 20.5. So I'd say you'd probably need to go for 60 to 120 seconds for you to capture this data. If you have a slower telescope, then you might need to go even beyond that, probably 3 to 5 minutes. And then you'd look at the third one, for example, that's 2011 UF21, and it's not necessary for orbital improvement. But you'd see the magnitude is lower, so it's easier to capture, but it's a bit slower. And then if you go even further down the list, you'll find 2014 RB13. This is useful for orbital improvement. It's a magnitude 20.5, 20.6, but it's extremely slow. So if you're capturing this, I'd suggest taking a single shot of around 3 minutes, and then coming back and taking another shot 10-15 minutes later for another 3 minutes, and so on and so forth. Ideally, you want to capture as much data as you want. My sweet spot is between 10 to 15 subs. That's where I find the best data to be captured. And then you have 2024, you can see it, not necessary. But I want to see if we can find any of the very fast moving objects. Doesn't look like it. But the fastest is this one right here. It's 2002 QHHY6. Not necessary for orbital improvement, but it's a magnitude 19. It's a fast moving object, but you can see it's slowing down. So it started as 7.3 and then now it's 6.92. But it's a nice target for you to try out. Again, you can start off with capturing data less than this if you want. So if I go back to the magnitude, and let's say, for example, I put in 17 and populate the data. So you'll find only 3 targets. So this is a Mag 14. Super easy to find with any of the telescopes that you have, whether it's a 6-inch, 8-inch. You'll take around 120 to 180 seconds, more than enough. And it's not super fast, but it's not super slow either. But you can see that this is not necessary for orbital improvement. The reason for it is it's a bit brighter than the others, so it tends to become way easier to figure out the trajectory. I can show you one more if we go to the magnitude, for example, 22. If I pick up the first 5 or 6, you can see the list becomes even longer and longer the higher the magnitude is, given that it's not easy to capture these asteroids at magnitude of 21, 22, or even higher. And you'll find, similar to the previous, when we were looking at 20.5, you'll see that this is useful for orbital improvement, this is useful, this is useful, useful. So you'd find the higher the magnitude, the more useful it is for the Minor Planet Center. But yeah, so that's the first step of what we do. The next step will be on Stellarium. Let me load it up and show you what we do. So guys, we're now on Stellarium, and the first thing you guys want to do is go to the settings under your configuration page, and you go to plugins, solar system editor, and configure. You get this pop-up window. Let me see if I can make it a bit bigger. Yeah, that's fine. And then you go to solar system, import orbital elements from MPC format, and then over here you'd go to elements of NEA, near Earth asteroids for current epoxies today, and click on get orbit. Now it takes a couple of minutes depending on how fast your PC is running. Usually Stellarium is a bit slow if you don't have enough RAM or hard disk size available. So you see all this list here. These are the asteroids from the Minor Planet Center. Now if you remember from the previous page, we were looking at a couple of asteroids. So in this instance, let's take this, although it's not something I'll capture, but just for the sake of demonstration, 2024 PU2. And then I'll come here on Stellarium and search for it. And you can see it populated it for me. And all I need to do is click the check mark, add the object. So once that's done, it's automatically available on Stellarium. Let's give it another minute for it to be done. So it's done. And then what you can do is search 2024, what was it? PU2. So don't worry if you see this, it's just because of the timing. So if I fast forward to later this evening, so you would see at around 10 it barely goes up, but then towards, I would say 11ish, that's when we'll be able to start capturing it. Let me do this again for you guys, makes it easier to see what we're looking at as well. So this asteroid is located really close to where Andromeda is, so it's between Andromeda and Pisces. That gives you an idea of where your telescope will be pointing later tonight. And then once you have this, you can find the coordinates on the top left and plug it into any imaging software that you use, be it SharpCap, Nina, Sequence Generator Pro. Any of these softwares will work. On Nina, there's a feature where you can just drag this automatically into Nina for the telescope to slew. So that's just a summarized version of how to capture the data. Again, I don't want to go into much details of analyzing the data, but then if you want to analyze the data, you have the free software Astrometrica. It's a bit slow, outdated, but it's very useful. You can see from here, that's how your trajectory is going to look like if you captured the asteroid. Another software that I've recently started using is Tycho. Now, this is not a free software, however, it's really good. If you have a strong PC with a great GPU, this is even way better. So hopefully you guys find this useful. Try it out. Let me know how it goes with you guys and if you are able to capture any of the asteroids. That's it for me. Hopefully I'll find you in another video where we discuss more and more about Tycho and Astrometrica. See you guys.